Welcome. Today we'll explore an interesting problem involving repeated differentiation of a trigonometric function. Let's start with our initial function. Let's break this down step by step. First, notice that we're given two equivalent forms of y. The first is y equals cosine cubed of x, and the second is 1/4 times cosine of 3x plus 3 times cosine of x. Now, let's find the first derivative. When we differentiate with respect to x, we get y sub 1 equals negative 3/4 sine of 3x minus 3/4 sine of x. Here's where things get interesting. We can rewrite this using the trigonometric identity that negative sine of theta equals cosine of theta plus pi over 2. Applying this identity, y sub 1 becomes 1/4 times 3 cosine of pi over 2 plus 3x plus 3 cosine of pi over 2 plus x. Let's continue this process. When we differentiate again, we get y sub 2. Notice how the coefficients change. The first term gets multiplied by 3 again. And for the third derivative, we get y sub 3. Do you see the pattern forming? Let's identify the pattern. First, the coefficient of the first term increases by a power of 3 each time. Second, the angle inside the cosine increases by pi over 2 each time. And the second term maintains its coefficient of 3. Therefore, we can write the general form for the nth derivative as y sub n equals 1/4 times 3 to the n cosine of n pi over 2 plus 3x plus 3 cosine of n pi over 2 plus x. And that completes our derivation. We've found a beautiful pattern in the repeated differentiation of this trigonometric function.